All right, here we go. This is the last lesson in Chapter 6, Lesson 6.4, kind of a combination of a few of the textbook lessons, 6.4 and 6.5. So if you're following along with the textbook, this is coming from both of those sections. So we're pulling some parts here on the triangle midsegment theorem from 6.4 and then 6.5 in the textbook, a section that covers triangle inequalities. So that's that. We'll go through a couple things here, and we'll split it. We'll talk midsegment stuff, do an example, and then do a couple of triangle inequality, apply that theorem in a couple different spots. So let's jump in. Let's get it rolling. First thing, definition. What is a midsegment? If we're going to use it and use properties of it, well, I guess I don't need to hide anything there. It's just, here's what it is. So add this to your notes. Midsegment of a triangle as a vocab term. The midsegment of a triangle, I'm just reading it off here as hopefully you're copying it down, is a segment that connects the midpoints of two sides of a triangle. So on the sketch, you can see here on the picture, if I ever ask you to sketch a midsegment, markings wise, we need to indicate, along the side of a triangle that I have a midpoint. So put a point about in the middle, a couple tick marks to show that, hey, that is the midpoint. Anywhere else, it doesn't have to go that way. I could freehand a triangle here, mark a midpoint here, mark a midpoint here, and it's the segment that connects those midpoints. So I think a fairly straightforward concept. Hopefully we're all right with that. Okay. Next thing, so there's what it is. There's how we sketch it. Next thing would be properties of. So that's kind of how we set it, just like we've done with a lot of these. You can say exactly that, properties of, or properties of a midsegment, just in that same portion of your notes. So there's two different things that we have to be aware of. So first off, we kind of just numbered and said that a midsegment is always going to be parallel to the third side. So the side that's not intersecting. So for us, if this is marked as a midpoint, which it is, and then I've got point E also marked as a midpoint. So obviously then this segment right here, DE, would be the midsegment. We just talked about the definition there. So the property of DE, the first one being applied, or that we're talking about here, is that it's always going to be parallel to the third side. In this case would be segment AC. So parallel. That opens the door for some stuff as far as, this right here and this right here being corresponding angles. So we could say angle BDE and DAC are congruent by the corresponding angle postulate. Just for example, not that we would use that in a proof, but potentially some algebra problems where I maybe know some numbers here and I'm looking for this expression here or something like that. So that's the first property, always parallel to the third side. And then the second one involves the length of the midsegment. It's always going to be half the length of this third side. So both properties relate to the third side. One is that it's parallel to this side, and the second property is that it's half the length. So obviously if this was 10, this would be 5. So the other way to say this, we saw this in the previous section too, there's different ways to kind of say the same thing. You could say the third side, segment AC, is twice as large as DE, so kind of depending on how you see things there. So there we go, two properties that we need to be aware of. Let's just do a quick example of where we would, I might ask you to do some of these problems, or a question that involves using the midsegment. So let's see what we got here. Pause it, sketch it, you try it, and I'll go through the solution right now. So as I see it, triangle ABC, all right, let's just make sure I know it's, for the notes purposes, of course, this is a midsegment, but when this shows up on a quiz or a test or a homework assignment, that it nowhere in here does this say midsegments or anything like that. So I've got to make sure that I'm able to take this information, use triangle ABC, where D, E, and F are midpoints of the sides. So D, E, and F are the midpoints of the sides. Say, oh, okay, that kind of triggers me to know that means DF, FE, and DE are all what we would call midsegments, right? So that's part of that figure interpretation. I know, like I said, for us, it's coming right after the midsegment note. So of course, that's kind of what we're using, but just making sure that we're taking some of this information into account. All right, what do we know? We know it's basically saying, hey, if I know, I'm going to start here actually, DF, I meant to switch, DF, let's see, the shorter one is 9x minus 3. And then we're told that BC, from here to here, is 12x plus 30. It's actually asking about EC. So I want to, in the end, this is kind of what I'm looking for, is the length of that segment right there. So there's there's actually two different ways we could set this up, and it's in words, what would we say? What's the property we talked about? Length of a mid-segment and its third side. We would say the mid-segment is half the length of this side, or what we kind of just finished with, this side right here is twice as large as this one, and that's actually literally how I'm going to set this up. I could choose to double the mid-segment length, which is 9x minus 3, and say like that has to be equal to 12x plus 30. Whoops, I forgot my x. 12x plus 30. Or, and I won't solve both, but I just want to make sure we're aware, I could choose to cut this one in half, say 1/2 times 12x plus 30. I could say, let's cut that one in half, and that would have to be equal to 9x minus 3. So you get kind of choice on that. It's not going to make any difference. We should get to the same spot on the solve. So I'll just solve this one here and say, all right, 18 x minus 6 equals 12x. I keep forgetting that x. 12x plus 30. Let's see, I'm going to subtract a 12x from both sides. I'm going to do this in one step. I'm going to subtract a 12x from this side and this side. And then I'm going to add 6 to both sides just to kind of, so I don't get too low on the screen here. So x's on here go away. 18x minus 12x is 6x. And then these kind of disappear. 30 plus 6 is 36. Finish by dividing by 6 to get x equals 6. Now that wasn't the answer. That's not what I was going for. It didn't say what is solve for x. A little bit of a follow-up here. How am I going to figure out what EC is? So even this one, there's a couple different options as far as how we want to do this. In class, a few people said, hey, you know what? Why don't we plug this 6 in right here? 6 times 12, 72. Add 30, 102. And then just cut that in half, because we know E is the midpoint. So I got half here, and EC would be equal to 51. I like it. All right, that's absolutely what the length of EC is. There's actually a second option there. Somebody suggested, why don't we just plug that 6 in right there? And you say, hold on, does DF have to be the exact same length as EC? And we didn't actually say that directly, but this segment right here, this mid-segment, DF, would actually have to be the same length as BE and EC, right? Because if we say DF is equal to half the length of this side, how have I marked half the length of BC? I've used a double tick mark to indicate that that's the left side. BE is a double tick mark. EC is a double tick mark. If this is equal to that same thing, that deserves a double tick mark. So kind of a long way of saying, if I wanted to, I could plug the 6 in here and go 6 times 9, which is 54, minus 3 is 51. We get to the same result in the end, but just making sure that we were aware of that. All right. So there's mid-segments, just an example of how we might use some of those properties. That's actually properties of mid-segments who identify unknown lengths in triangles. Wow, look at that. We'll do these out of order here a little bit. Let's go. We're going to switch to the second part of the lesson and use these inequalities in one triangle. All right. So we're up to the second half of the lesson already. We're doing great. So we kind of just, for a heading, we switched gears. Mid-segments kind of tucked away. Next heading we used was just triangle inequalities. Well, I guess I don't have to erase that, but we didn't call it the theorem. I know there's a theorem, and I don't mean to minimize it. It's something that's been proven. But the triangle, we just said triangle inequalities and their properties, or triangle inequalities. So this is actually what the triangle, we pretty much added this, that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. We wrote that pretty much word for word in class. And what we followed up with was, where does this come into play? More of a question of, is it possible to construct or build or draw or sketch a triangle with any three side, that's just going to be side lengths. Oh, darn it, switch colors every time I use that eraser. So if I said, hey, I'm going to hand you a segment that's 10 inches long. I'm going to hand you a segment that's 20 inches long. And then I'm going to hand you a segment that's 50 inches long. And my directions would be, I want you to build me a triangle that that uses those three segments. You say, all right, no problem. I'm going to start lining them up. What are we going to see is going to happen here? We'd see, all right, I'm going to lay the big side down first, right? The 50, that's the longest side. Let's get that kind of laid out here. 50-inch segment. And then, yeah, less than half of it, 20 of it, the 20-inch segment we can put like here. And I'm trying to be somewhat accurate with my picture. That looks like that'd be about a little bit less, just under less than half of the 50. And all right, where am I going to attach my third one? I'll attach it right here. A fifth of the length of the way, I guess. 10 inches. And what do we run into? What's the problem? Like picture this pink 20-inch segment. I can't move this. It's got to attach there, and that one's got to attach there. What's going to happen? Well, the problem is this 20 is just going to lay down flat right here. The 10 is going to lay down flat about right here, and we're going to have what? How big of a gap? A 20-inch gap that we're not able to reach. So, to answer this question, is it possible to construct a triangle with any three side lengths? Well, I hope that's a resounding no. Like we're not able to. So that's kind of what this triangle. We're basically going to use this triangle inequality to check. The problem would be we didn't meet this criteria. So if I pick these two side lengths, 10 and 20, the triangle inequality theorem says pick any two sides of a triangle, and when you add up their two sides, it has to be greater than the third side. Well, 10 plus 20 is 30. That's not greater than 50. That's kind of saying, well, then you don't have a triangle. All right. So a question that kind of goes along with that would be something like where I just basically do what we just did and saying, hey, can we construct a triangle with the given side lengths? I don't think we have to make a picture here. Kind of what it boils down to is we need to check the two shortest sides and make sure that when I add those two shortest side lengths together, they're bigger than the third, the longest. Okay, so for this first example, the 52, because obviously 28 plus 52 is greater than 19. We don't have to worry about that one, but it's got to be true for every single group. So let's look at the short ones. 28 plus 19. What do we got on that one? 47. And absolutely not. Like 47 it's supposed to be greater than 52, but it's not. It's less than 52. So this is one that I'd say, no, we're not able to make a triangle. And that's ultimately what's going on there. It's a yes or no question, but yeah. So here we go. Let's look at the second one. Where are my two short side lengths here? When we add 63 plus 38, I actually get exactly 101. So the question would be, is 101 greater than 101? And the answer would be no, it's not greater than. It's actually equal to, but that doesn't cut it. We'd have a situation where I'd have the 101, I'd have all this stuff laying on top of each other. So this is another one that we'd have to say no. I think when we get to the third one here, when I add up my short sides here and here, we get 58. And 58 is absolutely greater than 48. So this is the only one that we're seeing where it is possible, yes, that we could construct a triangle. So kind of a simple concept once we see it laid out like that, as far as making sure that your two short sides add up to be longer than your third. So that's an example of a type of problem that goes along with this triangle inequality theorem. There's another one here, a different type where, so again, I'll give you a chance. Obviously, you can pause, set it up, get some of the examples set up. It's given us two of the three sides. A triangle has one side length of 14 and another of 10. So it's telling you like that's unchanging. 14 and 10 has to be there. And what it's asking us to do is describe the possible lengths for the third side. So, we could pick numbers and try them here. So if I plugged in, is 1 okay to have for this side? Well, I could check 1 plus 10. Nope, that's not greater than 14. Is 3 okay? 10 plus 3. Nope, that's not greater than 14. 4, is 4 okay? 4 plus 10. It's equal to 14. We said we got to be bigger than 14. What about 5? 5 plus 10, 15. Okay, 5 work. I like that's greater than there. So I think 5 is okay. 6, yeah, 6, 7, 8, 9, 10, 10, 12, 13. What about something bigger than 14? Is that okay? 15, 16, 17. Well, now I've got shorter sides, 17. I'd be adding the 10 and the 14 to make sure they're bigger than this number. Here's kind of what we have to look at. So picture, if you can, it's hard because I can't really move the picture. When does this, so if I highlight this side of 10 and picture this kind of swinging down, it's fixed right here, but we're pivoting 10 down and getting closer and closer to this 14 side length. What's going on with X? It's getting shorter and shorter as we move closer to the 14, right? When does this stop being a triangle? It stops as soon as X hits that 4, right? Then we have the 10 and the 4 just laying out right on top of the green segment. So I think hopefully we see that, all right, we need X has to be, whoops, I kind of wrote it too close there. So X has to be greater than 4. So I like saying it that instead of 5, right? We kind of were just talking through it there. We said 5 was okay, but by saying it like this, saying X has to be just greater than 4, we're including numbers like 4.1, 4.2, 4.5, stuff like that. So this is a better way of saying X has to be 5 or greater, because that's actually not true. 4.2 is okay. And then let's look at this picture. I know the triangle's kind of rotated a little bit, but think about what's going on here. If I try to use the same colors, if I highlight the 14 in green and the 10 in red, now picture this pink one's kind of swinging the other way, this way. What's going on with X? It's getting bigger and bigger and bigger, right? As 10 kind of swings down, pivoting right here on this point. So X is getting larger and larger and larger. When does this stop becoming a triangle? When basically the 10 and the 14 are laid out in a straight line like this, right? The 10 would be laying down, and then we're no longer at a triangle. So what would the length of X be in that situation? Well, it would be laying right down on top of these. It would be 24 units long. So that's kind of the extreme. There's a far end extreme too, that X can't be any bigger than, and in our case, it's 24. So this is as efficient as we can get as far as saying, all right, there's a range of values, the possible lengths. X has to be greater than 4, but that same X also has to be less than 24. All right, so long story short, if you're looking for a summary piece there, a situation like this, the small end is the difference of the two known segments, so 14 minus 10. Go figure, that's where that 4 came from. And then 14 plus 10, when we laid them out kind of the long way, gave us that high end 24. Where students sometimes struggle, I see more, not figuring out the numbers, but what to do with this notation. So make sure you're always kind of opening up to the right, eating the larger number. All right. Awesome. Here we go. One last. So I think, if we're looking big ideas, we can definitely find the possible lengths of a third side of a triangle. If I know the lengths of 2, there was even one we threw in there, like, is it possible to build a triangle given some certain lengths? The last thing we got to look at is identify the largest and smallest angles and sides in a triangle. So that brings us to our last note of really the semester, chapter 6, however you want to say it. So heading, relating sides and angles of a triangle. This is kind of, I think, all we need. The note, if you wanted to write it, would be that the longest side of a triangle is going to be opposite of the largest angle. Okay, so I can't tell you specific numbers, but if I know right here that this is the largest angle, and it looks to be like an obtuse angle, if this is the largest angle, if I were to walk out from that angle, I'm going to run into the longest side. Okay, and it works the other way too, that if I were to know that this right here is the smallest angle, the arrow pointing to the small angle up here, without knowing numbers specifically, but we would be able to say that, all right, if I walk out from that small angle, I'm going to walk into the short side. So I think maybe it's like we've come full circle here, and it's like, wow, that's a really nice, hopefully simple concept to wrap our head around. So there's really just 2 types of questions that would go along with it, that we either get a triangle where I know all the angles. Sometimes I might ask you to go back and look at some concepts. Whoops, I didn't mean to do that. Look at a concept where maybe I don't give you all 3 angle measures. sometimes students are like, what, Mr. Kroll, you didn't give us enough information. I can't answer this question. How am I supposed to know which is the biggest angle? I'm missing one of them. Well, I'm kind of counting on us to be able to go back to the last chapter and know that, oh, hey, in a triangle, all three angles have to add up to 180. So 180 minus 80 minus 45. There's my 55. Okay, so just, I know that wasn't how this one was originally set up, but I think that's fair to ask you to calculate an angle measure. So I want to see all three. Once I know all three, I think I can answer this question. Just make sure the only other thing would be to make sure we go in the order that it's listing. I could ask you from long to short or short to long. So for us, it's asking what is the shortest side up here. If I want to find the shortest side, I got to look at the smallest angle measure. If I walk out from that, that means QR must be the shortest segment QR. So make sure you include the segment bar. Segment QR is the shortest side. The next shortest, or I guess the next largest side, would be the next opposite the next largest angle. So QP or PQ, segment PQ. And then the largest side up here is going to be opposite the largest angle. So segment PR or RP would be my longest side up here. Cool, that's simple. That's an easy one to figure out, hopefully. The flip would just be, just so we can see it here, I'll let you pause it and set it up, where it says list the angles of triangle PQR in order from smallest to largest. So again, we're not able to say numbers specifically. Like I couldn't tell you, well, actually I could, but there's ways to do this, but not for us. I'm not asking you, which is the smallest angle in this triangle? Well, I need to see the smallest side and just walk over to the angle. So angle P would be the smallest, right? We're going small to large again. The next, I guess if we're going up, the next biggest side is right here. So the next biggest angle has got to be right there, angle R. And then last but not least, we're looking at side 13 being opposite the largest angle. So angle Q. And obviously process of elimination, we could get that too, but okay. That's it. That might be one of the shorter ones we've done. So that's identifying the largest small angles and sides and triangles. So we did it. That's pretty good. I don't think there's any reason to drag it out, make it any longer. So 6-4 done, chapter 6 done. Yeah, that's it. I will see you in future lessons.